Welcome back to the deep dive. We have a fascinating stack of research to get through today, and I think for anyone listening who is actually building with AI right now, this is going to feel painfully relatable.
It's definitely going to hit close to home.
We are talking about the Model Context Protocol, or MCP.
Yeah.
And, specifically, we're looking at this moment we're in right now. It feels like we've hit an inflection point. We've moved past the, hey, look at this cool demo phase and smack into the, okay, how do we actually run this in production without going broke phase?
Exactly. The honeymoon is over. We are seeing a shift from, novelty to actual utility. But the problem is, as soon as you start trying to scale this up, moving from a prototype to something people use day in, day out, things get messy fast.
Messy is putting it lightly. The sources we've pulled together, specifically this new breakdown from the new stack, plus insights from CTOs at places like Merge and Linear, are describing what they call a scaling nightmare.
It's a dramatic term, but it really fits. The core issue is token bloat.
Right. And just to set the stage here, the promise of MCP is that you can connect your AI agent to everything. GitHub, Slack, your database, your calendar. But it turns out running all those connections simultaneously is like
Trying to drink from a fire hose?
Exactly. It creates a massive bottleneck.
It does. You have to remember, an AI agent's brain, its context window, is finite. It's like a workbench. You can only fit so many tools and manuals on it before you literally can't find space to do the actual work.
I love that image. And the numbers here are honestly shocking.
Yeah.
We've got Gil Feig, the CTO of Merge, weighing in. He says that when teams rush to add all these tools, the agents just get confused.
Right.
But the stat that really blew my mind, he mentioned the tool metadata alone, just the descriptions of the tools, not even the data they return, can take up 40 to 50% of the available context window.
Think about that for a second.
It's unbelievable.
Before you've even asked a question, before the AI has processed a single piece of your data, half its brain capacity is gone. It's just sitting there, mentally holding the instruction manuals for tools it might not even use.
That is wild. It's like hiring a genius consultant and then forcing them to memorize the entire phone book before they were allowed to solve your business problem.
And the implications are real. Feig points out that this causes latency to compound, your costs go through the roof because you're paying for those tokens on every single turn, and ironically, the agent gets stupider.
It gets stupider. It forgets what it's supposed to be doing because it's drowning in definitions.
Exactly.
So if you're listening to this and you're wondering why your AI builds are sluggish or why your API builds look like a phone number, this is why. Your agents are exhausted before they even start. But we aren't just here to admire the problem. Our mission today is to fix it. We are going to unpack 10 expert-backed strategies to rein this in. And what I love about this list is that it ranges from simple design tweaks you can do today to some pretty radical architectural shifts.
Like subagents and semantic routing. It's a great list. It really moves from the tactical to the strategic.
So let's jump into part one. This is the foundation, the design philosophy, strategies 1 and 2. The first strategy seems almost philosophical, design tools with intent.
This is where most developers trip up right at the start. The problem is that a lot of people take the path of least resistance. They take their existing REST APIs, which might have hundreds of endpoints, and they just wrap them one-to-one in an MCP server.
It's the copy-paste approach. I have an API, now I have an MCP server.
Right. And Alex Salazar from Arcade.dev argues that this is a huge mistake. He says most of those servers simply aren't built for agentic workflows. They're built for rigid software-to-software calls.
And when you dump that complexity on an agent, you're just creating noise.
A lot of noise. So instead of giving the agent the entire menu of a restaurant, you should just be giving it the chef's special.
Okay, I like that.
Marcin Klimek from SmartBear puts it really well. He says a tool should be like a specific API method, clear inputs, limited outputs, a single purpose. If your tool is vague or broad, the LLM wastes tokens trying to figure out how to use it.
Or worse, it hallucinates parameters that don't exist.
Exactly. So specificity is the token saver here. You're saying don't build a generic database tool, build a get user email tool.
Absolutely. Don't mirror every endpoint. Build the tool the agent actually needs to do the job. It reduces the cognitive load on the model significantly.
Okay, that leads nicely into strategy 2. Minimize upfront context. This feels like the Goldilocks problem of AI.
It really is. It's a balancing act. If you give the agent too little context about a tool, it breaks. It doesn't know what to do.
But if you give it too much, Like those heavy descriptions Gil Feig warned about. It gets confused and bloated. Kevin Swiber from Layered System points out that heavy tool descriptions actually make it harder for the LLM to choose the right tool.
So how do we find that sweet spot? How do we tell the agent a tool exists without weighing it down?
Neeraj Abhyankar from R Systems suggests a tactic called minimal schemas. Basically, don't load the full documentation and parameter list at once.
Okay.
Load a tiny, lightweight definition first. Just the name and a one-sentence description.
No, that's smart. So it's just a placeholder.
Exactly. Only when the agent decides, hey, based on this description, I think I need to use this tool, do you then expand the schema to show the full details.
It's like a read more button for the AI.
That's a perfect analogy. And Abhyankar notes that if you combine this with things like deduplicating your schemas and scoping tools into namespaces, you can cut token usage by 30 to 60%.
60%. That is a massive optimization.
It is.
And you aren't even changing the underlying code of the tool, just how you present it to the model.
It makes the system more responsive too. Less reading time for the model equals faster answers for the user.
Okay, let's move to part 2. We've designed our tools better. We're being intentional. We're using minimal schemas. But now we have a visibility problem.
Right. If I have a complex app, I might have hundreds of these minimal tools. Listing them all is still a problem.
Right. And that brings us to strategy 3. Adopt progressive disclosure.
I like this term. What does it look like in practice?
Well, think about how humans work. If you're a carpenter, you don't dump your entire toolbox, every screw, every saw, every drill bit onto the table before you start a job.
No. You open the drawer you need. You organize by category.
Exactly. And Tom Moore from Linear, and keep in mind their MCP server has like 250,000 users, so they have real data on this. He notes that most developers actually only use 1 or 2 core MCP servers at a time.
That's interesting. So we build these massive systems thinking we need access to everything just in case. But in reality, we're creatures of habit. We are. And Matt Martin from Clockwise backs this up. He says you simply can't have them all on at the same time. The fix is to separate discovery from execution. Build a tool hierarchy.
Like a file system.
Yes. Let the agent choose a category first, like calendar tools, and only then do you show it the specific tools inside that category.
So you're not scrolling through a list of 500 tools. You're clicking a folder, then clicking a file.
Precisely. You filter the noise before it ever reaches the agent.
But what if we want to get even smarter about this? Strategy 4 is automate tool discovery. This sounded really futuristic to me. The source called it a RAG for tools.
This is a fascinating concept. We usually talk about RAG retrieval, augmented generation for documents, finding the right page in a PDF. But Christian Posta from Solo.io suggests applying that same logic to finding the right tool.
How does that work?
Imagine instead of loading 50 tools into the context window, you load just one tool. Maybe it's called router or find tool. The agent says to the router, I need to check the weather in Tokyo. The router then searches a database of tools, finds the weather tool, and dynamically injects just that tool into the conversation.
So the agent doesn't even know the weather tool exists until it explicitly asks for something that requires it.
Exactly. Ori Itzaki from Sonar calls this semantic routing. You're only retrieving the top K most relevant tools based on the user's intent.
That feels like a game changer for scalability. You could technically have 10,000 tools available in your database.
But the agent only ever sees maybe 3 at a time.
Correct.
It solves the bloat problem by making the available toolset dynamic rather than static.
It's the difference between memorizing the encyclopedia and just knowing how to use a search engine.
Perfect analogy.
Okay, let's unpack this. Because if we're getting dynamic with tools, we probably need to get dynamic with the agents themselves. This brings us to part 3, structural changes. Strategy 5 is use subagents.
This is a move away from the monolithic agent. You know, the one super agent that tries to do everything. Write code, test it, deploy it, write the documentation.
The jack of all trades agent.
Right? And as we know, master of none. The problem with the monolithic agent isn't just token bloat, it's role confusion.
Oh, right.
Ankit Jain from Aviator talks about this. If you give an agent instructions for testing code and instructions for writing marketing copy, it sometimes blends them. You get marketing copy that sounds like a unit test.
Unit test passed. The product is good. Not exactly catchy.
Not at all. So Jane suggests breaking the task down. Instead of one giant agent, you have specialized subagents. You might have a read-only subagent that just looks up documentation. Then you hand off to a coding subagent. then to a testing subagent.
It's like an assembly line.
It is. And the benefit is massive.
Yeah.
Jane says token overhead drops by 50 to 60%, but more importantly, the testing agent doesn't get confused by the deployment instructions because it doesn't even have access to them.
It stays in its lane. That makes total sense. Why burden the researcher with the tools of the builder?
Exactly.
Now, strategy 6 is something that really caught my eye. It's called code mode, or code-based execution.
This is one of my favorites because it fundamentally changes how the LLM interacts with the world.
So how does it differ from the normal way?
Normally, an agent orchestrates a workflow in natural language. It says, step 1, get the data. Okay, I got the data. Step 2, filter the data. All of that chatter and all those intermediate messy results stay in the context window.
Clogging it up.
Right. Kevin Swiber calls code mode delegating the workflow away from the context window. Instead of doing the work step by step in the chat, the LLM writes a script, a piece of Python code, for example, that performs the entire complex workflow.
And then?
It executes that code somewhere else in a sandbox outside the chat, and the only thing that comes back to the context window is the final result.
Oh, wow. So you skip all the back and forth.
Completely. The context window never sees the intermediate data processing, the loops, the messy JSON blobs. It just sees, here is the answer. It saves a massive amount of tokens.
That is incredibly efficient.
Yeah.
It's like the difference between micromanaging someone standing over their shoulder saying, do this, now do that, versus just giving them a task and saying, come back when you're done.
It is. And it relies on the LLM's ability to write logic, which, modern models are actually very good at.
Okay, so we've overhauled our design, our discovery, and our structure. Now let's talk about hygiene.
Yeah.
Part 4 covers strategies 7 through 10. These feel like the eat your vegetables part of the deep dive, but they seem crucial.
They are. They're the operational guardrails. Strategy 7 is semantic caching.
Which is basically, don't do work you've already done.
Pretty much. If a query comes in that matches a past query, just reuse the cached response. Don't hit the LLM API. Don't refetch the tool definitions if they haven't changed. It's simple, but it's effective.
Strategy 8 is remember prompt engineering. Melissa Rusi from Pomni brought this up. Why is prompt engineering a strategy for token bloat?
Because tools are connected to the LLM unsupervised. If you don't give strict instructions, the model might hallucinate or loop or call the wrong tool repeatedly. Strict prompt instructions and examples are your first line of defense against an agent going off the rails and burning through tokens.
Right. Garbage instructions in, garbage token usage out.
Exactly.
Strategy 9 is data hygiene. Marcin Klimek had a great quote here. Do not repeat large outputs. Summarize them instead.
This is huge. Developers often let the agent dump massive JSON objects into the chat history. Like, here's the entire customer database, and then that data sits there being reprocessed for every subsequent question.
It's dead weight.
Total dead weight. Klimek suggests fetching data incrementally. Get a summary first. Get an ID. Only request the heavy, detailed data if you absolutely need it for the next step.
It's about being disciplined with what you let into the memory.
Yes. Treat the context window as a scarce resource, because it is.
And finally, strategy 10. Consider externalizing control.
This is about the boring stuff that takes up space. Governance, authentication, error handling.
The paperwork of the software world.
Right. And Alex Salazar and Christian Posta both argue that you shouldn't put this logic inside every single tool. It bloats the tool definition.
Sure.
If every tool has a paragraph about how to log in securely, you're wasting thousands of tokens.
Where does it go?
You move it to a runtime layer or an agent gateway.
So the gateway handles the security check, and the tool just does its job.
Exactly. It keeps the tools lean and consequently keeps the context window clean. It's separation of concerns applied to AI infrastructure.
So what does this all mean? We've gone through 10 strategies. Design with intent, minimize context, progressive disclosure, all the way to external control. It really feels like we're growing up.
That's the perfect way to put it. We're moving from the wild west of early adoption where we just threw things at the wall to a mature engineering discipline.
But the sources also gave us a bit of a reality check in the outro.
They did. Ankit Jain pointed out that adoption is still messy. Individual developers are just bolting on tools without thinking about the cost.
And on the flip side, enterprises are paralyzed because they can't predict how much this is going to cost or how it will behave.
It seems like the big takeaway here is that optimizing MCP isn't about finding one magic trick.
No. It's about system design. It requires shifting our mindset from just giving the AI tools to designing architectures using gateways, routers, and subagents that manage those tools intelligently.
It's creating an ecosystem where the AI can thrive, rather than just dumping it in a library and hoping it finds the right book.
Exactly. It's about curation, which this is where it gets really interesting for me, though. We spent this whole time talking about efficiency and structure, but I want to leave you with a thought.
Go for it.
We are building systems where routers decide what tools are relevant, gateways manage governance, subagents stay in their lanes and only see what they are allowed to see. Are we? Are we actually just recreating corporate bureaucracy inside our code?
That is a haunting thought.
Right. And if the router agent decides which tools are relevant for a task, does that router become the new single point of failure for creativity? If the router doesn't think a tool is relevant, the creative agent never even sees it.
You're right. You're optimizing for efficiency, but you might be optimizing away the serendipity that makes AI so powerful in the first place. The ability to connect two unrelated things.
Exactly. If the marketing subagent is never allowed to talk to the engineering subagent because of efficiency, do we lose the innovation that happens at that intersection?
That is the ultimate trade-off, isn't it? Efficiency versus exploration.
Something for you to mull over as you build your next MCP server. Are you building a genius or are you building a bureaucrat? That's it for this deep dive. Thanks for listening, and we'll catch you on the next one.
Goodbye, everyone.